All right. Hi, everybody. Welcome to the first day of Unit 4. Um, we are, this is actually our second to last unit for the semester. I know that's kind of a little bit weird to be thinking about that we're already like only in October and we're already mostly done with the semester, but I think you're doing a really great job, and I think the pace that we're going at is really appropriate for the number of classes that you have, and so things are going well. Today we're going to jump into parabolas and quadratic functions. You probably have seen some of this stuff in Algebra 9, but it might be a little bit like from the part of the year where it was like you kind of don't remember a lot. So we are going to jump into this stuff. Um, the vocabulary is really important in this unit, and I want to be really clear about what's on the learning target so that you know exactly what you're expected of. Expected to be able to do, and then we'll jump into some of the kind of starting stuff. So here we go. Okay, so right away I'm going to start with the vertex of a parabola. The vertex is the point right here. Um, it is the part where it's the spot where the graph either goes from increasing to decreasing or decreasing to increasing. Um, and it's kind of like that, the bottom part of the U, or maybe it's the top part of the U, depending on which way it goes. Sometimes you might have parabolas that open upwards, like this. If your parabola looks like this is the vertex. If it looks like this, then this is the vertex. The y-intercept is where the graph crosses the y-axis, and this is sort of the same vocabulary as what we use for lines. Just kidding, I wrote x. I meant the y-axis. So right here is where the y-intercept is on this blue graph. For this one, it should have been right here. This is the y-intercept. It's where the graph crosses the y-axis. X-intercepts then make sense to be the spots where the graphs cross the x-axis, which would be here and here. For this graph, it's actually the same point as the vertex because it crosses the x-axis or touches the x-axis right there. Line of symmetry sounds kind of like a geometry word or set of words, but we can apply that to algebra 2. The graphs are symmetrical, and so if you like put a line right through here and you folded that graph over on top of itself across that line, then they would be overlapping. And so that's how I know that that's a line of symmetry. For this red graph, it would be right here. Given that information, what I want to tell you about is like what the purpose of this unit is. And so basically the big idea is I'm going to be giving you equations that match or create those parabolas from the previous slide. And then your job is to identify all of those features from those equations. I might also give you the graphs and you have to find those features. I might give you graphs and you have to find equations for those graphs. And then we're also going to be using parabolas to model projectile motion, which is really just like throwing things in the air. So maybe I'll drop something off the top of the building if I can figure out how to get up there or something. I don't know. We'll figure something cool out. The other thing that we're going to do is use some parabolas to model some data. So kind of like we did with the COVID data from Unit 1 and 2, we're going to see if we can use similar data, maybe different data, to use parabolas to model that data and then make predictions and figure out things that we should know about relationships that we can use in data. This is definitely not the most exciting part of the unit, but I do want to just kind of talk really quickly about what is on the learning targets and what looks like an 8, what looks like a 7, and kind of the differences there, especially for the first two learning targets. So the first learning target is graphing and identifying features. So that means, can you take an equation in any of these forms? So there's a couple different forms here, 1, 2, and 3 different forms, and find those important parts of the graph. So I already have them highlighted here. So these are the things that I'm really looking for you to be able to find. I want you to be able to do it in any of these forms that I underlined. And so When I'm talking about a mastery of the objective, I'm talking about you can do this given any of these forms, and you're flexible and you can just make this work for everything. If you're working in the 7 range, then that means that maybe you're only comfortable with one or two of the forms. I mean, two of the forms, and then if you're in that key gaps area, then that means that you're really only cool with one of the forms. So there are some pretty significant differences there, and I need to see you being really flexible and working with all of the different types of forms. So make sure that you are super confident on all those things. I do recognize that a lot of this vocabulary is totally new and a little bit overwhelming right now. But as we get into the unit, I just wanted to be really transparent about what is it that's going on. How are you going to get the grade that you need for this learning target? Super similar situation on learning target 4B. 4B is solving quadratic equations, and I'm going to be giving you equations that look like this, and you have to be able to solve them. You have to find the values for x. Again, that mastery means that I'm looking for you to show me that you have two methods in your playbook, in your wheelhouse, two methods that you can use to solve those equations. If you're only using one method, maybe you're just using the quadratic formula, I don't know, just saying, then that's really only proficiency, because I'm really looking for that you know multiple methods and you're flexible about figuring out which method is best. I will kind of speed through these other ones just because they're a little bit less difficult to understand what I mean by mastery and proficiency. Regressions and projectile motion is the sort of application stuff that we're going to be doing. And then the last one is using some complex numbers. Complex numbers you maybe haven't seen much before, but they are another way of representing answers to quadratic equations. I'm going to kind of hold off on talking about those until later in this unit. On the next slide of your Nearpod, you're going to click on this link, and you're going to see a graph that looks a little bit familiar from previous units, but then you're going to kind of read through the stuff that's on the left side of the Desmos screen. You're going to see like some words and then some equations. And then there's some circles, and I might be telling you to click or uncheck these circles as you go. And then different things are going to show up on the graph over on this side of the screen. So mess around with that. And then when you're done reading through and thinking about the questions that I'm asking you on Desmos, come back to this Nearpod.